Hello and welcome to the fourth and final part of our Let's Code ESP8266 series, where we will finish up on the CO2 and volatile organic component monitor. We will let it have a web interface, and I did this and noticed, well, last time we did a lot of stuff and it turned out to be quite a long video. So this is the sketch, the Arduino sketch from last time. It has roundabout 111 lines of code, and we did a lot of stuff. We defined the input-output pins, initialized all the hardware, so both the CO2 sensor and the humidity and temperature sensor, and did the whole hardware setup and the loop where we would average stuff and collect it and write it out onto the serial console, which is all very nice, but it's already a lot of code. And in the end, it turned out to be that we have like 3 times as much lines of code, and it would be a very, very long video indeed if I would do that, and I also don't want to split the video further. So what we'll do now is I will walk you through the code and show what things I have changed and what things are new. So some things haven't changed, of course. You see there's still the defines up here that we had, but we also have a couple of new defines and things. Namely, 2 new libraries here from the Arduino IDE. One is the ticker library, which will come in very handy if you want to call functions in your program regularly, and basically it acts as an interrupt timer, and it will break the program flow and execute the function that you run on the ticker, because the ESP and the Arduino platforms, they don't run any kind of operating system, not in the usual sense anyway, because they're microcontrollers. So you don't have any processes, you don't have multitasking, you don't have threads. Everything is done in the run loop. The only way to get some kind of asynchronicity is, well, the most easy one at least, is through this ticker library, for example. And another thing, since we want to do a web server here, we need to include the Wi-Fi library for the ESP, which lets you do all the connection to the Wi-Fi, and we will also have a web server and a client in there, but we'll come to that. So what else did change? I refactored this whole thing a bit to make it more readable, actually. So after all these defines here, which will come back in a minute probably, you see the averager structure, which is the same as before. The print function is the same. I folded all this stuff so that you can better see. And then we have basically 2 large blocks. The setup block, which is this one here, and the loop block down here. So the setup block will do 3 things. It will do the hardware setup, which we did in the last episode already, here in the setup function as a whole, but I refactored it so we have a separate function here. We can take a look in there, and it did not change. This is the whole same code as before. Then we have the Wi-Fi setup. The Wi-Fi setup will do the connection to the Wi-Fi network. So how does it work? First of all, we wait for a couple of milliseconds for the device to settle in, and then we will try to connect to the Wi-Fi. And for that we get the Wi-Fi class in Arduino, and we can do Wi-Fi, or for the ESP, there we can do Wi-Fi.begin, and we have to pass it the SSID and the password. And then we run a busy loop, and while the status is not yet connected, we will wait for half a second and then retry. Or basically wait, honestly. And only if we successfully connected to the Wi-Fi, we will start our web server, and then we will print out which IP we got, so that on the serial monitor we know where to go to. You can actually also use the name of the ESP, so the ESP will also create a name, something like ESP 12345 or something. This part here is, I think, the MAC address of the Wi-Fi interface, and you should either be able to just browse to HTTP ESP12345, whatever the name of your device is, which you can see on your router, for example, or the MAC address should also be printed on your ESP. Or with some routers you need to put a .local back there, or with the popular Fritz boxes, also the search domain .fritz.box will work. All these options should work, and otherwise you can just use whatever is printed here to access your device. And you can also tell your router to give always the same IP address to this device, which should also be the case with most modern routers nowadays. Okay, so where do we store the SSID and the password? I did another rework. I put all the static variables into a header file. This shows up as a new tab above at the top here. And you can do this by just clicking on this little triangle here and say new tab. And everything that you call .h will be treated as just a header file. Or if you call it .c or .ino, I guess it will be concatenated and linked to the main program. But we only want to include this for readability reasons. So here you have it, the data file. It's huge. I put all the statics that we will need up here. And also for the Wi-Fi setup, you put a string with the SSID and the password here to make everything manageable here. And of course also the Wi-Fi server that you just saw. So this is the web server listening on port 80. You can put any port here, but port 80 is the standard port. Then you can just use HTTP without specifying it in the browser. All right, and down here comes the HTML code, but we will have a look at that later. But you have to put it there as well because, well, you have to put it as a string into the program because you can't read any files, at least not to my knowledge. Okay, so we included all the stuff. We did the hardware setup, we did the Wi-Fi setup. And what we'll do now is we will actually use the ticker object that we instantiated up here, static ticker ticker, and we'll attach one function that we call every second, and we call this function collect data. So we already saw the Wi-Fi setup. Now we have the collect data function, and the collect data function is already known to us. That's actually our old busy loop here. So the old main loop is now the collect data function. This will be triggered every second by an interrupt, and it will be executed. And it has the averager, and it has some extra stuff, so we can average over, or we can plot stuff over 10 minutes and over the last 24 hours, but it's basically the same. So I renamed a few variables to make it more inline, but we still have this stuff here for the logging. And the only new stuff that I added are these two blocks. And taking a look at the data definition, we have a couple of new arrays. These are the arrays. We have an integer array for keeping all the values from the last 24 hours of CO2, and one array for the last 24 hours of TVOC data, and also one for the last 10 minutes, because usually you want to have an overview over the short-term development of your air quality, but also how was the last day, more or less. and this here is just define which computes how many entries I need. If I want to have one sample every 10 minutes, and here one sample every 10 seconds. You need not be concerned with that right now. You can look it up in the source code if you want to. And we need to keep track on where we write into the integer array. This is basically a counter which will wrap around, and we will continuously plot this stuff. And yeah, it's basically a ring buffer, and we will always plot the last n values that are in this ring buffer. Okay, so this is the same way that this part worked. We compare if enough seconds have elapsed, and if so, then we will write a new value into the two TVOC and CO2 arrays, and we will increment the counter. And this modulo operator will make sure that this whole thing wraps around. So this is actually a ring buffer. And the counter is also the index into the ring buffer later when we print out the HTML. So this is not that much new. This will be called every second. And you will be able to see that on the serial monitor. And what do we do now in the main loop if we don't collect any data anymore? Well, we do two things. We will check if we are still connected to the Wi-Fi, because we might lose connection and we don't want to lose any data and have to restart. So what we'll do is we'll actually check regularly if we are still connected. And this works like this. While the status of the Wi-Fi interface is not connected, and we have retried a maximum number of 5 times, we will increment our retry counter, and we will tell the Wi-Fi to disconnect, just a safeguard, to turn off, and then to turn on again, and then to again try to connect, and then we delay for a couple of milliseconds. If this did not work after 5 retries, we will simply reboot the machine. And this stuff here was from a nice Medium blog post. I will put a link to that in the video description. That guy has some nice ESP stuff on there. And it actually helps with stability for the Wi-Fi connection. All right, so that's that. And then the second function that we use is the web server loop. The web server loop, does not much either. So first of all, we create a Wi-Fi client, and Wi-Fi client is returned by server available. So we already set up the Wi-Fi web server, and the available function will return a client object. And if that object is null, it means there was no client which tried to connect, and then we just simply return. And then the loop continues. But if there was a client that connected, we will see if the client will actually connect successfully. So we make another busy loop while the client is not available. We will wait, but we will count the milliseconds that have passed. And when the milliseconds that have passed are more than 5,000, so 5 seconds, we determine, well, probably the client has died or fallen asleep, or I don't know, and we tell it to stop, and we just return and ignore that client request. I tried before without this part here, and as soon as I was attaching some mobile device, my whole thing would stop. I would get the new client message, and nothing would happen ever anymore. I could still ping the device, but the client was basically dead, and the TCP socket wouldn't time out. I'm not sure if the TCP sockets on the ESP have a timeout. Probably takes a very long time. So checking if the client becomes available for a couple of seconds and then just killing the client is actually the way to go. So this makes it absolutely robust. You should definitely use this whenever you deal with some TCP client. Yeah. Anyway, this is a very simple web server, so we don't even try to parse the request. We assume that the user just wanted to get the main resource. So you can basically post or put or whatever. We will just ignore the request and just read until the first carriage return. And also print the request for debug purposes, and then simply write the HTML response, always the same. This is a very stupid web server, of course, but we want to keep it simple, and we don't want to make it more complicated than necessary. You can, of course, send any request here and you will get the HTML response. But my goal was that we don't need an additional server, because there's people using like MQTT to push everything to a cloud server and then you collect it from there. But I think that's way too complicated. I just want to have a simple device that outputs HTML on port 80 and you can just watch it in the browser. Very, very simple. Anyway, we will write the HTML response and then again tell the client to stop, close the connection, and that's that. This will be run in a loop. The question, of course, now is what does the HTML look like? And this is basically it. And this looks a bit complicated. I already split it up into a bunch of strings here, and what I simply want to show you is the raw HTML data, which is here. And this is much more easy to understand if you look at it like that. I assume that you know at least a little bit of HTML. The important stuff here is I decided to use a library called Chartist, which is pretty nice. You can find it on GitHub. And it's a very, very small JavaScript library to produce very nice charts, which are highly customizable. Any kind of charts, from line charts, bar charts. You see there's a whole ton, even pie charts and ring donut charts. So yeah, there's really a lot. And the important thing is it doesn't have any external dependencies, which is great because we want to do as little stuff on this device as possible. I mean, this will be run in the browser, but still it will make the HTML so much more complex if we started to use, I don't know, AngularJS or Vue.js or I don't know, any kind of this stuff. And all the other chart engines that I looked at had a lot of these dependencies. So what we're doing is basically do only the minimal amount. We take the style sheet for the Chartist from a CDN network that supplies this for free, so we don't have to put it on the device itself, and also the minified JavaScript code of Chartist. I will also use a CDN minified version of Bootstrap, because it makes your website look a tiny bit better. So Bootstrap was originally by Twitter, and it's now a community open source project for websites, and basically everyone uses it because it makes HTML rendering a lot better looking and has a lot of nice containers and stuff, and makes mobile rendering possible due to being responsive, etc. And it's actually pretty simple. So we just open up a container, a Bootstrap container, put in 2 rows. The first row will have 2 columns, and the second row as well. And in the first column, we will put the 10-minute stats chart. And to make this happen, you just need to do 2 things. You put in a div with a Chartist class type, ctchart and ctperfectforth. This is the type that I want to have. And we have to put an ID here for the style, basically, that we apply here. And then you need a script. This is the actual magic, so the script will run Chartist JS, and it will replace this div here with the SVG rendering in the DOM. And you can put any kind of options here. It's all very well documented. I just want to have a simple line graph with lines on the y-axis, and the data, you can put labels in here and some series, and the series will be whatever values we have. So you can put any number of values here, but we will of course generate it in the program. Same goes for the 24-hour stats. There's nothing different here. Same thing, just slightly different names. And then the second row, we just put the temperature and the humidity. And in the end, we need to include more Bootstrap JavaScript stuff to make it work. But this is all from a CDN, so that's fine, I think. That's all the HTML. I used an Emacs macro to convert that into C-style strings, because you need to escape all those double quotes. Basically do this here, and you need to put everything into double quotes as well. And then you can copy everything into the header here, and then you end up with this nice stuff. So we have a couple of parts: the header HTML, the first middle part, the second middle part, and then the footer. And in between we'll put the dynamic data. It's not nice. You could do this in a more restful way, but since we're on a microcontroller, we just keep it very, very simple. So the response, first of all, we need to speak HTTP actually, and then, oh, now I have a double doc type here. Oh, doesn't matter. It doesn't hurt. The browsers usually eat this, because I already put that up here. So maybe we just remove that. Then we print the header HTML, and then we need to also print the data series. And the data series for the 10-minute chart is just simply an iteration over the number of samples that we took. And you remember that was something that I defined above. And then we just simply print from our ring buffer, and we index with a counter and just add the I on top. And again, we need to wrap around because we might read over the end of the array, so we do the mod 10 minutes. And same goes for the TVOC data. Very simple, very, very simple. And here is the same stuff. And also in the second part, after the first middle HTML, we do the same for the 1 day. We just have a different number of iterations that we do, a different counter to jump into the ring buffer, and we also need to wrap around. This is everything, and the only last little magic is that we also output the temperature, which is stored in this static variable, and the humidity as well. And then the footer, and everything's done. Now you've seen, honestly, really everything. The whole thing will compile just fine, I hope. And then we can have a little look. This is what the whole thing looks like. The left chart is the 10-minute stats, the dark curve at the top is the CO2 values, and the lighter one at the bottom is the TVOC values, scaled up by a factor, of course, because these are parts per billion, and these are parts per million, if I remember correctly. We also see the temperature. I think it's a little bit too high. My watch says it's 20 degrees outdoors, so maybe a little bit warmer inside, but I don't think it's 29 degrees in here. Humidity 40%, that's believable, I think. And the 24-hour stats, because it hasn't run for a long time, is on here, and it's at the moment just a jump like this. And after 24 hours you will see a similar curve to this, of course, so you can run this overnight and just check back in the morning. And the HTML will also do a refresh every 10 seconds. So this is very, very simple because we don't do anything particularly clever. There's just a meta refresh in here every 10 seconds. and that works actually reasonably well. So yeah, that's about it, and it actually looks pretty decent on a mobile device as well, especially in landscape mode, but I think also in standard portrait mode. It is responsive design, so that should scale pretty well. And we don't need anything except for the ESP and the 2 sensors. You don't need any cloud server, you can just run it on your local network. And I think that's pretty nice. I will put up the new version of the Arduino sketch on GitHub, link in the video description. And yeah, play around with it. There's tons of room for improvement, of course. You can make it a cloud solution, you can smooth the values better here in the graphs, because these are just samples from the averager. And yeah, there's a lot that we can still improve on, but I hope you learned something, and please do share this video, like it, and most important of all, do subscribe if you want to. And other than that, I wish you a very nice evening.